Sensible heat. We call it sensible heat not because it makes sense, hopefully it will make sense, but because we can touch it, we can feel it. So the molecular motion in an object moving around creates heat, and that causes the molecules in our fingers to move around, and through conduction we can feel that heat. So we're going to differentiate that kind of heat from a phase change of heat, of energy exchange. But let's start now with just sensible heat. So it turns out it's very hard to measure sensible heat in any absolute sense. We're always talking about a change in energy, and this is very common in thermodynamics. We talk about an exchange of energy or a change in energy. And so we're going to define sensible heat using a derivative, a change in energy, and it's going to be related to the mass of the material and the heat capacity of the material and the change in temperature. So E is the internal energy. M is the mass of the material. And T, of course, is the temperature, and we use absolute temperature, or we can actually use relative temperature. So we can use either Kelvin or degrees centigrade because we're talking about a change. So a change in 10 degrees Kelvin is the same as a change in 10 degrees centigrade, but we typically talk about degrees Kelvin in thermodynamics, so we're going to start with that. So the mass, of course, is going to be in units of kilograms. And then in energy, we use the joule, right? So this last term, this heat capacity, since this is a joule and this is a kilogram and this is degrees Kelvin, this heat capacity has to be in units of, to end up with joules, we have to have it in joules per kilogram per degrees Kelvin. Okay, so our units are going to be in terms of those. So we talk about the change in energy, and you can see how the change in energy occurs when you change the temperature. The energy changes. So when the temperature goes up, the amount of internal energy also goes up.